so yesterday we talked about, we haven't done this yet in terms of our notes, but we do have enough knowledge about parallel lines to be able to work through how to set these up. Just trying to make it so that they can actually see. Great. There we go. Okay, so yesterday we took some super important notes. So possibly the most important notes that we will have in our packet. And it was this little chart, okay? And so on this chart, it tells us, let me zoom back out for a minute. It tells us that when we have parallel lines cut by a transversal, the following stuff is true. That our alternate interior and exterior angles, so any alternate angle pairs are equal. Corresponding angles are equal to each other, and our vertical angles, just like always, are still equal to each other. And then it also told us that our same side interior angles are going to be supplementary, okay? So that is what we are using to work through this warm-up. So what type of angle relationship do we have here? We have alternate interior angles. So these are alternate interior angles. And what is the relationship for alternate interior angles? They are congruent or supplementary? Congruent. Alternate interior angles are congruent, which means that x plus 116 is equivalent to that 110-degree angle on the alternate side, okay? Because they are alternate interior angles, we know that they are congruent or equal to each other in measure. And all I have to do is subtract the 116 to solve for x, which is -6. Okay. What type of angle relationship do I have on the second example? These are same side interior. One kind of hint that I've used in past years is that same side starts with an S, supplementary starts with an S, helps you kind of link them together. So same side are supplementary. That's one way to kind of help you remember what their relationship is. What does supplementary mean? So to say same side are supplementary, what does supplementary mean? Equals 180. So my setup, my equation setup is going to be different here. Instead of equal to each other, I know that one angle, which is 24x plus 4, plus the other angle, 21x minus 4, equals 180. Okay, that one angle plus the other is going to equal 180. And combining like terms there, how many x's do I have? 45x. And what happens to the 4's? They cancel out. So 4, -4 cancel out, gives me 180. And I divide by 45. How many times does 45 go into 180? What do you think? 4 times. Yep. Good. Okay, so different relationships means the equation is going to look differently. Sometimes they're equal to each other. Sometimes they're equal to 180. What type of angle relationship do I have on 3? Alternate exterior. Alternate exterior angles. And alternate angles, exterior or interior, are congruent, which means this angle equals this angle, or 7x plus 17 equals 80. And if 7x plus 17 equals 80, then I can subtract 17. And 7x equals 63. And divide by 7. 9. And x equals 9. Okay, so we've seen alternate interior, those are equal. Same side interior, those are supplementary. Alternate exterior, those are equal. What type of angles do we have on 4? What's that angle relationship? Those are corresponding angles. So corresponding angles are on the same side, but one is inside and one is outside the parallel line. So these are corresponding angles. What are corresponding angles? They are equal or congruent to each other. So that means that 12x plus 7 equals 127. Or 12x equals 120. And x equals 10. In terms of knowing which is which, literally they're all equal except for the same side, interior or exterior. The only other thing that we listed as supplementary was what we had already talked about last unit, which is linear pairs. So if it's making a line, okay, so if I have parallel lines and I'm making a line here, and I have a linear pair, then that's supplementary, but that's from last unit. That has nothing to do with the parallel lines. Okay, so in terms of the new angle relationships, the only one that we mark as supplementary is the same side interior, same side exterior. All the other new relationships we have are congruent to each other. Okay. Okay, so now what I would like for you to do is find your notes. Let's start there and we'll do homework last. In your notes, find page 8. That's where we left off yesterday. And what do you know is on page 8? What we just did, exactly. Yeah, so some more diagrams. So on page 8 of our notes, we have some more diagrams. Now, I would say these are a little more challenging diagrams. So we'll look at them together. But we have more diagrams. On number 1, our parallel lines are just tilted the other way. This is my transversal. So note, see the arrows? That's showing me parallel. So these two lines are parallel. This is the transversal that's cutting it. Now what's different from this diagram than the ones we just did is there's more than one variable. No big deal. Okay, x has a certain relationship with this angle, 105. We know this angle here. And y has a certain relationship with 105, and we'll just have 2 equations that we have to solve. What is the relationship between x and 105? They're congruent because they are what we call those angles? Corresponding. Yeah, these are corresponding angles, which means they are congruent. Okay, so I know that 3x is equal to 105. And then I just have to divide by 3, which gives me x equals 35. Okay, so I solve for x. What is the angle relationship between y and 105? They are same side interior, which means they are supplementary. Same side interior, supplementary. Now there's actually 2 ways that I could do this. Like if I knew that these were congruent, I also know that this angle here is 105. Like I know that's 105 and I know that's 105 because they're congruent. And I just said 3x equals 105. So I could have also used the linear pair here, right? Like that this and this are making a line. Either way, this is supplementary or same side interior supplementary. Whichever way I look at it, the equation should be that 5y plus the 105 equals 180, right? That's what supplementary means. So whether I could think about these angles or I think about this line that's being created, I know that 105 and that 5y have to add up to 180. Or subtracting 105, 5y would have to equal 75. And what is 75 divided by 5? What do you think? 15? Okay, so no big deal that we had two variables. That just meant we had two equations that we had to work through. And you will certainly see stuff like this on our quiz next week, okay, where we're solving, it's a little algebra in with our geometry. Okay, on our next one, it's like a polygon, right? It's a quadrilateral. But if you can see the arrows here, that's saying this line is parallel to this line. And I find it helpful to sometimes extend the parallel lines when diagrams look weird like this. So I'm going to extend the parallel lines. I can do that. Okay, I know that I have parallel lines here. And if it's helpful to you, you can also extend the other lines. So I have a transversal here, and I have another transversal there. So if it's helpful to you to kind of alter the diagram a little bit, as long as you're not changing anything and just extending lines, that's fine. Let's start with y. So I'm going to cover this up. 5y is on that transversal. And the only other thing we know is that the bottom angle is 90. What's the relationship between 5y and that 90-degree angle? They're what? They're supplementary because they are same side interior, exactly. So I know that these are same side interior angles. Same side interior angles, which are supplementary, or that 5y plus 90 has to add up to 180. Okay, I can see that on that transversal, they're on the interior, and I know that has to add up to 180. Or subtracting 90, that 5y equals 90, and dividing by 5, y equals 18. Good. Now the x's, they're not related to these angles at all, because these angles, this 90-degree and 5y, okay, they are on this transversal. The x's are on this transversal. So they don't have a relationship going this way. The reason they don't, like I can't say that those are supplementary, is because these are not parallel lines going this way. Okay, so the angle relationships are only true with parallel lines. These are my parallel lines. So to solve for x, I gotta look here. Again, I have what angle relationship? Yeah, these are still same side interior. But we just want to be careful not to set up, like I can't go this way in this particular diagram because those aren't parallel. And I can go this way. Same side interior, again, is supplementary. So I know that 8x plus 4x equals 180. So those two angles together add up to 180. Or that 12x equals 180. And I divide by 12 and get x equals 15. Okay. Last diagram. I'm going to give you a minute to look at this one. It is a little bit challenging. I want you to notice these are parallel. So this line and this line, they are marked parallel. They have that little arrow here to show that they're parallel. But these two lines are also parallel. So I can extend them if I want. Okay, but I have two sets of parallel lines. Why can't I start with this pair? Well, it's okay because they're on these blue parallel lines, but I'm going to get stuck. Why? Because this has a, and that is a y. So don't let that trick you. I have this here too, and I can use the orange parallel lines, know this relationship, and set something up. So I'm going to give you just like 30 seconds to think about what would this relationship be? And so then how would I set it up? Okay. What's their relationship? Yeah, so on these orange parallel lines, y and 140 are in same side exterior, same side supplementary. Okay, show you with me? So these are same side exterior, which means they're supplementary, which means that 140 plus y has to add up to 180. Supplementary means those two angles together will add up to 180. So what does y equal? Y equals 40. Okay. What's the relationship here then? These don't have a relationship, by the way. Okay, 140 is not on the same transversal as the 2x. So I got to go here. They're on this same yellow line. What's the relationship here? They're on the same side, but one's in, one's out, so they're corresponding. Corresponding angles are congruent. Corresponding angles are congruent. So that means, and before we couldn't really get started here because I would have had 2x plus 10 equals y. And we would have had an x and a y and we wouldn't really be able to move from there. But I know that y equals 40. I've already solved for y. So I can plug in 40 for y because I've already solved for it. Y equals 40. And now I can solve from there. So 2x equals 30 and x equals 15. Okay. Good. So before I go and do the proof, you had homework last night, homework number 16, and I said just do the first page. On the second page of homework number 16, let me get a blank copy. There's a few more of these. So I'm going to give you a minute on the second page of that homework, okay, to look at these diagrams, and there's a lot of variables going on there, okay, and try to determine how can I solve. And keep in mind, like z, y, and x, I can't match any of those up until I know one of them. So I got to figure out 70 can match with one of these. Only one of these can 70 go with. Start there, get that variable, and then build from there. Same idea here. I have an x, a z, and a y. So I need to figure out which variable can I link up with this 60, start there, and then build. So I'm not going to give you a ton of time, but a little bit to get started on some of these. And then we'll go over them together. So that's why I'm kind of, you didn't have enough time to finish this. Like we said, on the first one, I have to start here because this is the angle that I can link to 7D. How do they link? What is their relationship? They're same side interior. Same side interior. This angle and this angle are same side interior, which means they're supplementary, or that together they add up to 180. And what does x equal? X equals 110. Now, because I have other pieces in this diagram, I'm going to fill that in. I'm going to put in 110 here. Hopefully that helps us see that this angle and this angle we can also link together as as corresponding, that they're congruent. So they're one in, one out on the same side here. So I know that 4y plus 14 equals 110. Now, if there had been like over here, there's more going on than just the variable, then I'd have to figure out what the actual angle is, not just what the variable is. But in this case, the variable is the angle because it's just 1x there. Okay. And then I'd subtract 14, which would give me 4y equals 96. And dividing by 4, what is y equal? 24. Okay, so I've gotten x, and now I've gotten y. Now I also know that these are congruent. We use that to solve for y, which means I also know that that angle itself, that right here, is also 110. Okay, these are supplementary, 70 and 110. These are congruent, so I can label this also as 110. And then the last angle that I need to find is z, or the last variable I need to find is z. And I would say I can link z to this angle, which we know is also 110. And these angles are what? These are also corresponding. So I'm going to go up here. So 3z plus 8 also equals 110. And 3z equals 102. Divide by 3, and what does z equal? 34. Now, I just want to point out, there are other ways that I could have filled this in. Like if I knew this was 70, another thing I could have done is say, well, this creates a line, so this must be 110. And then I could have used this and this together to find z. Like there's other ways to work through it. And in fact, knowing that this is 70, I could fill out this whole diagram because I know my alternate interior angles are congruent as well. So I would know that this is 70 and then these alternate angles, so this would be 110 as well. Okay, knowing those angle relationships, if I know one piece, I can kind of work through the others. So I chose to work here and then here and then here, but there were other ways I could have also done that. Okay. So here we have another diagram. Here's some parallel lines going this way. These lines are also parallel, and again, if you want to extend them, that's fine. We know this angle, so I need to start here. If I'm just going to look at where my variables are placed, which variable can I link to this one right now? Right, yeah. So I know that these angles are corresponding angles. So if this is 60 degrees here, then this is 60 degrees here. And I may want to just put that in because now watch this. Okay, just watch. These are corresponding, so I know they're congruent, so we'll use that in a minute. But these are alternate. Are alternate angles the same? Yeah, so I also know that when I get to x that I'll use 60. Okay, and up here, these two angles create a line. So what is the angle where z is? It would be 120. Did you say 120? Yeah. Okay, because this has to add up to 180. So do you see, given one angle, I can move all around that diagram. I just need to move carefully. Okay, so by having that 160, I was able to figure out what all of the variable angles are equal to. So I have 2y plus 10 equals 60, or 2y equals 50 and y equals 25. So this is the mistake some students make, is then they go, oh, if that's 25, then that's 25. Do you see that mistake? Like y equals 25, but this angle is 60. So this angle is 60, this angle is 60 because they're alternate. So then 3x equals 60. Or x equals 20. And then we use this line that was created there to know that 5z equals 120. And dividing by 5, z equals 24. Okay? So that's one piece here. And let me look real quick. I want to look at the checkout you have for over the weekend. I feel like that's in there, but I don't want to misspeak. Hold on. Yeah, so the checkout is 2 pages. On the first page, you just need to identify the relationships. So here are 2 angles. Are they alternate interior, alternate exterior, same side interior, same side exterior, corresponding, so on. Okay. On the second page of the checkout, this is what it's assessing. Okay, and they are not as involved as this. They're more like our warm-up. Okay, where we have a single variable and we just need to decide what's the relationship and then solve. Okay, so that's your task between now and when we return. There will not be proofs on that initial checkout. There will be proofs at the end of next week when we take our, what I'm calling a quest, because it's our only assessment this unit. So it's like a quiz, but it's also the test for the unit. Okay, so that's next week. Okay. So let's wrap up our notes, which will get into proofs. So if you go back to your notes, there's one more page in notes 2, and it's at the top, has a whole lot of font, a whole lot of writing. And I'm going to point out a very important word at the top of this page. So yesterday, oops, I can't see that. Yesterday, we talked a little bit about this with the if-then statements coming back for this unit. So notice here that it says, if 2 lines are parallel, then the following is true. Okay, so we're going to use a lot of this. If this, then that. And the way that that looks in our proofs, okay, so now it's listing what's true. If 2 lines are parallel, alternate interior angles are congruent. Alternate exterior angles are congruent. Corresponding angles are congruent. Same side interior are supplementary. Same side exterior are supplementary. If I'm using one of these things in a proof, I use the if-then statements. So if, for example, I'm just going to do one for these 2. I can say, if parallel, then alternate interior angles are congruent. So I shorthand it a little bit. That's what my reason would be in a proof, okay? If this, then that. If parallel, then alternate interior angles are congruent. By the way, it's true both ways. So I could also say, if alternate interior angles are congruent, then the lines must be parallel, okay? Because that is only true when we have parallel lines. So we go both ways with that if-then. If parallel, then this is true, or if this is true, then the lines must be parallel. Same idea here, okay? For corresponding angles, I can say if parallel and corresponding angles are congruent, or vice versa, okay? These could flip and it would still be fine. Okay, if corresponding angles are congruent, then parallel. If we're using the supplementary in a proof or to fill in this little conclusion reason piece, Okay, same idea. We're going to have an if then. It's just going to look a little different. So if parallel, then same side interior. I should put angles. Angles. Okay, same side interior angles are supplementary. Or the other way around. If that's true, if the same side interior angles are supplementary, then the lines must be parallel. It works both ways. The only angles that we wouldn't use this if parallel then that, or if that then parallel, would be the ones that have always been true, that were true last unit as well. So not with vertical angles or linear, I'm gonna run out of space, pairs. Okay, so if you're using that angles are congruent because they're just vertical angles, then your reason is just that they're vertical angles because those are always congruent no matter what. Or if you're using that angles are supplementary because they're creating a line, then your reason is just that they're a linear pair, okay, or that they're line, you could write a whole sentence if you wanted to, okay, angles that are create a line will total 180, okay. So that would not be an if-then statement. That's just that's true, okay? So here we have, given 3 and 5, what type of angle relationship are 3 and 5? Alternate interior. So if I'm told that these are congruent, then that tells me that these lines must be parallel, because those alternate interior angles are only congruent if the lines themselves are parallel. So my conclusion, if I know that 3 and 5 are congruent, my conclusion is that line M is parallel to line N. Okay, so if that was my proof, that would be my statement. If that's true, then I can make this statement. The reason I can make that statement, my reason category, my proof, that'll be where the if-then statement comes into play. So I'll say if, and we said these were alternate interior, right? So if alternate interior angles are congruent, then the lines are parallel. If this, then that. Three sup 6, that means supplementary to 6. What type of angles are 3 and 6? Same side interior. Again, if these are supplementary, my conclusion is that those lines are parallel. The reason I can say those lines are parallel is if same side interior angles are supplementary, then the lines are parallel. You see that, how that works? And again, it could go the other way. We could prove angles congruent if I knew the lines were parallel. What type of relationship do 1 and 5 have? Corresponding. These are corresponding. So what I can conclude is those lines are parallel then if those angles are congruent. And the reason is using that corresponding angle piece. So if corresponding angles are congruent, then parallel. So we're going to do a proof together. So you want to draw your two columns. Statements and reasons. What it wants us to prove is that A is parallel to B. So here's A and here's B. Okay, so what you don't want to do is get confused looking at these proofs and think I'm looking for a relationship between these two lines. That would be an easy mistake to make. I'm looking for a relationship between these two lines, which means I either need angles here or angles on the transversal up there. So it looks like what two angles would help me, given that these are the lines I want to be parallel. Not even looking at the info I have, which ones do I want to be able to say are the same or supplementary? So 2 and 3 are corresponding, but on this pair of lines. That's the tricky piece. Yeah, I want 1 and 3 because 1 and 3, if I could say that 1 and 3 are congruent, then I have alternate exterior angles and then these lines would be parallel. I would know these lines are parallel. So that's kind of like one way to prep yourself for the proof is what's one thing I could say that I could use those if-then statements for. So to find these lines parallel, one thing I can use is if I can say 1 and 3 are the same, then I can say those lines are parallel. So I'm not given that. What I'm given is that angle 1 equals angle 2. That's given. And I'm going to mark that 1 and 2. 1 and 2 are not on the same transversal, so that doesn't help me in terms of proving them parallel right now. I'm also given that 2 is congruent to angle 3, given. So 2 is congruent to angle 3 also. Now we can see in our diagram that 1 and 3 are the same. Why can we say it? What is that called? Starts with a T. Transitive. Yeah, so if 1 is congruent to 2 and 2 is congruent to 3, then 3 must be congruent to 1 or 1 must be congruent to 3. Okay, and that's kind of linking these two together. They're both equal to 2. Okay, they're both equal to 2, so then I must be able to say that they're equal to each other. 1 is congruent to 3. I also usually accept like a substitution there because technically you could say 1 is congruent to 2 or 2 is congruent to 1. So I can take this and plug in 1 for it. Okay, but when you have kind of this series of statements, we should be using transitive property. Okay. Now, if 1 is congruent to 3, that's what we prepped ourselves. We said we wanted that. So now I can say those lines are parallel because if what? What did we say those angles were? If the alternate exterior angles are congruent, then the lines must be parallel. Okay. So that wraps up notes 2. Very important notes. Kind of the most important notes for this unit would be all of the notes 2. What I'd like to do is go through the homework 16 now. So you should have done the first page. So I'm going to give you answers to that first page. Now what you were doing here is you were saying, you can zoom in on half of it because it's hard for the people at home to see. Okay, is you were saying, what's the relationship between these angles? And based on that relationship, are they congruent or are they supplementary? Okay, so this is that first column. This is what you should have had from your homework last night. And then on the other side, Again, what's the relationship and what does that mean? On the bottom half of this, we have two sets of parallel lines. It doesn't say they're parallel for both of the examples. It starts by just saying if ST, which is here, is parallel to UV, which is here, name all the angles that would be congruent to angle 3, which I have marked here. So if these two lines are parallel, here's angle 3, it's on this transversal. All of the angles that would be congruent, I could have literally, where's my notes, just used this table to know that I should have an alternate pair, a corresponding pair, and then vertical angles. Okay, so in this table where it says what are my congruent angle pairs, so from 3, again on this transversal, 3 and 13 are alternate, 3 and 15 are corresponding, and 3 and 1 are vertical. So those are the angles. If those two lines were parallel, those are the angles that angle 3 would be congruent to. Then it says if these two lines are parallel, name all the angles that are congruent to angle 8. So for that, I'm looking here because I'm looking at these blue parallel lines. And again, congruent, so I'd have alternate. Angle 2 is congruent to it because it's alternate. Vertical, angle 6 because it's vertical. And corresponding would be angle 4. Okay, so I was working through that diagram to figure out what 3 angles would be congruent to it if that was true. Okay, now let's look at the back side. So you haven't done any of this yet. This first part is the same idea. So it starts by saying if angle 2 is 80, so I'll fill that in. Let me use a pencil so I can erase it. If angle 2 is 80, then what would the measures of 6 and 7 be? Okay, we want to find them a measure of 6 and 7. Anyone want to help with this? What do you think? 6 is 80 because 2 and 6 are corresponding angles. Okay, so I would know 6 is 80 because these are corresponding. Now 7 is creating a line with 6. You see it? Okay, so 7 should be supplementary to 6, or 7 should be 100. And I'm using a linear pair there. Okay? Then it says, if angle 9 is 105, find angle 10 and angle 16. Which angle can I find first there? Yeah, 10 is the only one that's related to 9. So 10 and 9 create a linear pair, which means 10 must be 75. It's a linear pair. And now 16 is not related to 9. This is out, that's in, and they're on opposite sides. That's not a relationship. What 16 is related to is 10. So if I know that 10 is 75, then I know that 16 is 75 because they're alternate interior. So I'm building from the first part into the second part where I know that angle 16 is also 75 because it is alternate interior to angle 10. It's kind of fun, right? It's like a puzzle. Okay, I want you to try the next one. So angle 8 is 85, is what it's saying. And it wants you to find 16 and 10 again, okay? But you're changing the info you have. So angle 8 is 85. If that was true, then what would 16 and 10 be? So take a moment and think about it. What do you think? Which one's related to 16? Or which one's related to 8? 16. Yeah, so 10 and 8 are on different transversals, so I can't link these directly, but I can link 8 and 16 directly. They are corresponding, which means they're congruent. So angle 16 in this case would also be 85 because it would be corresponding to angle 8. And then angle 10 would be 85 because it is alternate interior to angle 16. Good. Last puzzle here. So it says, well, what if 15 was 95? Then what would angle 8 be and angle 1? This one's the trickiest one because 8 and 1, neither of those angles are related to 95. Neither one. What angle could I use that is related to? There's a couple options here. 7, I could use 7. So 7 would be what? 95. 7 and 15 are corresponding. So I could totally use 7. 7 is 95 as well. And if I know 7 is 95, then 8 would be 85 because they create a line. Then 8 would be 85. Good. So angle 8 is 85, kind of having to problem solve through that. Now, 1 is not linked to 8, but 1 is linked to, I could use 5, or I could use 7. 1 and 7 are alternate interior, or alternate exterior. Okay, I know 5 because these are vertical. So I know 5 is also 95. And then I could use corresponding to know that 1 is 95. Okay, but it's a puzzle, and it kind of slowly you can spread out and find all the angles given one angle. You just have to be really careful. Okay. And at the bottom of our homework, we have a quick proof. So we'll do that together, and then I'll let you get yourself prepared for checkout and not being here until a week from now. This only gives us one line for the given. So we'll write both givens on the same line. ST is parallel to QR, and angle 1 is congruent to angle 3. When I am given something, I'm going to then mark that in my diagram. So this is kind of a funny diagram. I have this triangle here. I'm going to color code. So this line and this line, and notice I'm also extending them a little bit, just helps me visually. Okay, they are parallel. And then I also know that 1 is congruent to 3. Okay. Then it says 1 is congruent to 2. How do we know that? What are 1 and 2? 1 and 2 are corresponding. So this is flipping the if then. On the other page, we said if this is true, then the lines are parallel on our notes. For this one, we're saying these angles are congruent. So my if then is I already know the lines are parallel. So I'm saying if those lines are parallel, then corresponding angles are congruent. Okay, you see how we sometimes need to use it one way, sometimes we need to use it the other way. If my statement is about lines being parallel, then it's the other way. If my statement's about angles being congruent or supplementary, then it's this direction, that I know they're parallel, so the angles are congruent. And what we want to prove is that 2 is congruent to 3, so that should be what's here. And the reason I can say that is because I have 1 is congruent to 3 and 1 is congruent to 2. So 2 is congruent to 3. What's that property? Transitive or substitution. In the key I wrote or substitution, so that's posted in there. Okay. So in terms of homework between now and then, we aren't using this packet. We're using the checkout that's posted online, okay? Please make sure that when you submit that you use a really, really clear, like make sure your pencil's sharpened and you get a good photo. It'll make it near impossible for me to see and grade, okay? And then Tuesday,